This lecture is on the philosophy of mathematics. I would just like to say that this is my vision of thought over several decades. I have never done any research on this. I don't know what anybody else thinks about it, but this appears to me to be the philosophy of mathematics. Mathematics is somewhat reliable for physical systems, but is totally unreliable when concerned with spiritual systems. I'll demonstrate that in a minute. When man started out, I guess he had very little need for math, as was hunters and gatherers for so many generations. But at some point, man decided to had to keep track of things. Maybe he had some animals he collected, or later grain, or maybe some tax collector just actually wanted to keep track of how much the taxes should be. So at some point, somebody just said, well, you know, we could put a rock or a stick could represent each of the items we have. And if we've got like 5 items, so we could have 5 sticks here. And if we had 20 items, we could have 20 sticks. But after a while, that would not work too well, because you get around 100 or so, you start having too many sticks or too many marks. So over time, this evolved, that someone thought, well, how can we shorten all this? What if this equaled 5 of these? And what if this equaled 10 of them? Well, then we could divide a system where we could have 1, we could have 2 items, we could have 3 items, and then we could also subtract 1 from this 5, and so we could develop a system here that eventually allows us to count. Whoops. And of course, we know that as Roman numerals. Roman numerals were good for keeping tracks of things, but I suspect it'd been very hard to take a square root with Roman numerals. So over time, Arabic numerals appeared. Arabic numerals have one great improvement. They've added 0 to the situation. And so now we have a numbering system that starts with 0, and that we can repeat over in the next sequence. We can add 1 to it, and we can make a tens place, which allows a whole bunch of flexibility and a whole bunch of things that we can do within describing models of our reality. But we always need to remember that the mathematics is just a model of the reality. It's always once removed from it. In electronic circuits, I've measured many of them in my life. I've got a degree in electronics and spent several decades in the computer industry. I've put together circuits and measured them, and the mathematics in the circuits never exactly match. I don't care how simple the circuit is, you can't exactly match it. But mathematics is a good representation of it. It's a good way to understand every aspect of the circuit. Arabic numerals not only took in 0, but they took in negative numbers. This is a concept that didn't exist in Roman numerals, because in the Roman numerals we're just keeping track of things. So it makes no sense to have 0 of things or to have minus of things. But in Arabic numerals, those are very, very positive things. But the problem with all mathematics is it tends to fail at the extremes. The inverse square rule is just like this. It's used to determine the gravity of a planet or the signal strength of something. And what it says is that the strength is inversely proportional to the square of the distance. So as you square the distance, the strength gets progressively less and less. But there is no end point to it. Newton said that everything in the universe had a gravitational connection to everything else, but gravionics says it can only have a gravitational connection with those things of which it is actually connected. So it tends to fail at the extremes. If we look at a planet and we look at the gravitational space of it, there is a limit somewhere to every physical system of how far that gravitational space or a signal extends. Imagine if you're driving across country and you pick up a radio station, you'll get it for a while, and then after a while you'll get out of the range of it. Every radio signal, every gravitational system has a limit to it. But since there's no limit in here, this fails when we approach infinity, because this doesn't represent reality. So the mathematics is good for a whole bunch of things, but it's wrong at a bunch of times too. It tends to fail at 0 also, since there is no 0 in nature. If A scientist was wanting to calculate an orbit, and this was a planet, and he had a moon here. What he would do was calculate the 0 point on here. He would estimate the weights and size of all these things, and then he would design an orbit based upon a simple calculation. But gravity doesn't have that opportunity. If you looked at the real gravity of the world, it's really distorted. Places that have denser material have denser gravity, and nature is connecting all of these up with this body. There is millions of connections. And so there is no zero in nature, and so when mathematics approaches zero, it usually fails. So physical and spiritual systems are totally different. Mathematics is almost useless in spiritual systems. One example is that mathematics says if one man can shear sheep in 10 minutes, then 10 men could shear the same sheep in 1 minute. But the reality of the situation is they couldn't do that. They would be so in each other's way that they could not accomplish the task. That is good mathematics, but it does not apply to the real world. Another example is that if people stand for a certain amount of spiritual or intellectual value, mathematics would say that 3 of them would be 3 of those values. But the reality is when human beings work together, even 3 people working together become a far greater force than any one of them working alone and all 3 of them working alone. And so it might be better described as the square of the number of people rather than the simple arithmetic sum. So what we've seen is that mathematics is always a model. It works in some cases, it doesn't work in others, but it's up to the mathematician to decide what is real in their equations and what is not. Thank you.